So we're looking at similar shapes. Now, first of all, a similar shape when in mathematics is where we have two shapes that are pretty much identical to each other in terms of their angles. Their angles are going to be exactly the same. So this angle here is going to be exactly the same as this angle here. This angle in this corner is going to be exactly the same as this angle here. And then you've got a right angle here, which we can see is also present. So first of all, mathematically similar shapes have corresponding angles which are equal. So that's one of the first statements we need to make sure we've got down, a key point about similar shapes. Now, their corresponding sides are also in the same ratio. Now, when we say corresponding sides, what we're referring to is, for instance, this side here, 3, corresponds to the 6 here. And the ratio of 3 to 6 is exactly the same as the ratio of 5 to 10, which is another set of corresponding sides. So here's 5 to 10. So then we've got 5 to 10. And 4 to 8 is also another corresponding set of sides, 4 to 8. And if you look at all of those ratios, they all actually simplify to 1 to 2. So if you look at this, this simplifies to 1 to 2, 1 to 2, 1 to 2. Okay, so that's why we've got all of them simplifying to the same thing. So that's firstly the most important thing about similar shapes, that their corresponding sides are all in equal ratios, and that essentially what we have is one shape is an enlargement of the other. So how much has it enlarged by? How do we figure out this scale factor for enlargement? Well, if you look at a set of corresponding sides, so for instance, if I look at how we go from the 3 to the 6, from the smaller shape to the larger shape, we can see that we need to multiply by 2. So if I did 6 divided by 3, that tells us that I need to do multiplication by 2 in order to go from the smaller shape to the larger shape. So in this case here, the scale factor for enlargement then is said to be 2. So we can make a note of that. The scale factor of the enlargement is 2. So that's the key elements for similar shapes, is that one is an enlargement of another. So then we can find what this scale factor is. And once we found the scale factor, we can go from the smaller shape to the larger shape by timesing by the scale factor. And we can divide by the scale factor to go from the larger shape to the smaller shape. So here we're trying to show, first of all, that triangles PQR and RST are similar. Now, if we want to show that these two triangles, PQR and RST, are similar, we need to first draw them out side by side, such that they are in the same orientation. So let's go and draw PQR. So we can see where PQR is. PQR is here on my diagram there. Now I'm going to draw this, but I'm going to rotate it such that PQ is my base. And when PQ becomes my base and I redraw it, then what I will have is I'll have Q here, I'll have P here, and I'll have R here. Essentially what I've done is I've taken that shape and I've rotated it around to make PQ the base. So Q ends up being the bottom left corner and P ends up being the bottom right corner. Now I'm going to then go and draw my triangle RST. RST is shown here. And if we draw RST next to this, we will then have both the triangles in the same orientation. We've got S there, we've got T there, and we've got R there. So we've got our triangles drawn. But within that triangle, we've got a few lengths that we need to indicate. So we know that the length PQ is 5, so I'll go and put that in here, 5 centimeters. We know the length PR is 4 centimeters, so go and put that in there as well, 4 centimeters. We know the length S to T is X centimeters, so that's an unknown. And we know the length R to T is 8 centimeters. We'll go and put that in there. So now that we have our two similar shapes, we need to go and answer the question, and we need to show how PQR and RST are similar. So this is a reasoning question. So part A, let's go and do the reasoning part here. First of all, we need to say that angle here, angle RQP, must be the same as angle RST. So must be equal to angle RST. Now what would be the reason? Well, let's go and take a look at that in the actual main diagram. And in the main diagram, let's identify where RQP is. It's there. And we're saying that angle is exactly equal to angle RST, which is here. Why would they be equal? Well, as you can see here, the line here and the line here are both parallel angles, parallel lines, as indicated by those red arrows that we have on the lines. And so therefore, angle PQR and angle RST are alternate angles, okay, because we can see that Z shape in there. So there's our alternate angles. So these two are alternate angles, and we'll write that down here, alternate angles, and that's why they are equal to each other. Next thing that we need to go and show is that angle RPQ is equal to angle RTS. So let's go and identify those in our main diagram. So angle RPQ, which is here, must be equal to angle RTS, which is here. And again, why are they equal to each other? Again, we can use the same reasoning here. We've got parallel lines, and as we can see here, those two angles that we've just identified are alternate angles. Okay, so they too are alternate angles. So I'll write down the reason. Lastly, we need to go and show that the angle QRP, so this angle here, must be equal to the angle, let's write that down, QRP must be equal to the angle SRT. What's the reason for that? Well, let's go and identify those two angles first. So angle QRP is here, and angle SRT is here. Why must they be equal? Well, we can see they are vertically opposite each other, vertically opposite angles. And therefore, we've shown that all three angles of each of those triangles correspond to each other. And so then we can say, therefore, triangle PQR is mathematically similar to triangle RST. So that's the first part of the question done. Now we need to go and find the missing length. Now this is where we need to think about how much one shape has been enlarged by. So what is the enlargement scale factor? So in order to do that, find two corresponding sides. Okay, a corresponding side from the smaller triangle against the larger triangle. So we can see that the corresponding sides that we are referring to here is this side here, which has a length of 4 centimeters, corresponds to this side here, which has a length of 8 centimeters. Now, using those two corresponding sides, we can figure out what the scale factor is. So what is this scale factor? I'll make a note here. Scale factor is equal to 2, as we can see here. 8 divided by 4 is 2. So there is our scale factor. So let's make a note here, first of all, that our scale factor for part B of the question is scale factor is equal to 2. So now that we know the scale factor, we can then use this scale factor to figure out any other missing length. So let's go and look at this corresponding side. Its corresponding side is there. So then we can say here that 5 times by 2, which is the scale factor, should get us x. So therefore, x is equal to 10 centimeters.